कहाँ पे भी है? हाँ Jules?
Okay, so last week we worked a lot. And any questions here? By the way, if you're having problem with the bound, if bound is not working, just set your bound instead of static to dynamic for now. Let's go into. Okay, so if you have done everything and still you are having problem not getting the IP address, just set this instead of static to DHCP, and then just comment this out or remove it, and then you should get an IP. Because what we have is this is not a perfect environment here. So, but at your work, you will be working with a network team for these things. So, all right, let's see here. Okay, over here at the end, I put in. Remember, I told you there is more than 65,000 ports, and these are the most popular ones. All the other ones are turned off, and when the application is installed, those ports get turned on. Okay. Okay, so today I'm gonna touch a little bit on the boot process when the system is booting up. What is actually happening?
So,
All right, guys, can you go on mute the moment you log in? Okay. So, um, let me bring this up. Okay, so you've seen the system is booting, coming up and all that. So what is actually happening when the system, the moment you turn the power on, and by the time it comes up to the login screen, there are a lot of activities happening here. Okay, so so let me give me one moment here. Okay, so I'm going to start the system here. I'm going to restart it. And when the system is starting, I just push the escape key to see more stuff in the background here. So when the system is starting, it's running through a lot of checks and configuring the system to come up in the, and then okay. Okay. So what just happened here? I mean, there is no way I could stop this. So what just happened here? The moment you turn the system on, what happens is it's the power is initialized. The system power is initialized, and there is a chip built into the system. It's called BIOS. Okay, BIOS is basic input output output system. Okay, so you have seen a menu comes up. The moment you turn it on, it will tell you that you have only a fraction of seconds or so that you could bring that menu up. It's called BIOS. Okay, let me see if I could bring that up here. Okay, F12. Okay, so this is a virtual machine here, but this is a boot menu here, but I'm not sure if I could show you the BIOS menu. Okay, let me search online. Okay, remember I asked you guys to turn the virtualization on? So what this is you go to the BIOS menu. This is what the old BIOS menu looks like, and it has all the basic input output information in there. So what is BIOS is actually it's a built-in chip. It's a built-in chip, on the system board. And what is this is this is outside the operating system here. So the moment you turn it on, the system goes and the BIOS initialization happens. So the BIOS kicks in, and what does BIOS do? BIOS is actually checking up on your system. Okay, so let's see here. Okay, BIOS. Hmm. Okay, these are more in-depth definitions here, but what it does is, in a nutshell, BIOS does is it checks the system and makes sure it's ready. So, and then you could also go into a BIOS menu. You could go into a BIOS menu. This is a BIOS menu, and then you could make some changes here. You could like if you want to boot from the CD all the time, you could make those changes here and save it. Next time the system boots up, it will behave it will behave the way you want it to behave here. Okay, there's a picture here. This is actually a chip, and it has a little a software running on it. It's called firmware, and that firmware is the moment you turn it on. This is where it kicks in, and it initializes the system. Okay, so what happens is it initializes the system here. So once the system check is done, the system check is done, what happens is BIOS passes control to first stage of bootloader. Which resides in MBR. Okay, so what is happening is after that moment here, let me see if I could quit B to continue. Okay, so right now, okay, so this is a bad example. So all this is happening so fast that you can't really see this, or even if you could see it, it's hard to stop it. So just in concept, the BIOS, it passes the controls, and there are two stages of MBR, master boot record. MBR stands for master boot record. Okay, so let's take a look here. Master boot record. Okay. Okay, so let's see here. Okay, master. Okay, give me a moment here. Come on. Okay, so what it is master boot record is actually a little space on the hard drive itself. It has master boot records. What it does is it has the record how to boot the system up. So this is something not new, and it's been used almost in every system here. It has a master boot record. So there are two stages in there. So first stage, it handles the information that is coming from the BIOS, okay, and so the BIOS passes control to the first stage of bootloader, which resides in MBR. Okay, so then what happens? The first stage passes the control to second stage of bootloader. Okay, um, so first stage passes control to second stage of bootloader, which resides in slash root slash root. I'm sorry, slash boot partition. Okay, so let me see if we have that in here. So what's happening here is there is a boot partition. It So the process is going on as such. It's passing control from one responsible system files to another. So BIOS happens, then it passes control to the first stage of bootloader, which resides in MBR, master boot record. Master boot record is this is the one that kicks off the system, and then after that, the first stage, which is in MBR, it passes control to second stage of bootloader, which resides in boot partition. So bootloader is the thing here, which is partially sitting in MBR and partially sitting in the boot partition here. Okay, so the second part of the bootloader, what it has is it has the kernel in here. Okay, so this is the kernel. This is the kernel that is sitting in here in your system. So what it does is it passes control to this here, and this is responsible for next. This is the next in a boot process. So what happens is at the second stage of bootloader, so it takes the responsibility, and second stage of bootloader initializes the kernel. So I'm sorry, I misspoke a little bit earlier. This is the kernel that gets initialized. So there is a file in here. We can't see it here. Let's see. Okay. Uh, okay, I'm not sure if this is the file I'm talking about, but there is one file that initializes the kernel. So this is the kernel here. This gets kicked in. This gets started up. Okay, so let's see. This is the kernel. Okay, so what is the kernel going to do now? Once the control is in the kernel, what is kernel? Kernel is a little software between the hardware and the operating system. Okay, so let me. Okay, kernel is nothing but it's a seed. It's a seed of the operating system here. So this is the hardware, and the kernel sits between the hardware and the software here. But it's a part of a operating system. Okay, it is a part of a operating system, but it's a small, very small code of instructions in here that it takes over. Okay, anybody have any questions so far? So all these things are happening within like a few seconds here.
But Zafar, is kernel is merely the instruction set, or is it's little more than instruction set?
It is a general little more, but I mean, we are not going that deep. But it's heading. It is a liaison between the application and the hardware.
Okay, and when we say application,
Kernel is the one
that
that. I'm sorry.
I
Yeah,
was saying that when we say applications,
you're
so
breaking up.
oh really? Okay, then I'll pass on if I'm breaking up. I can't do anything.
Yeah, I mean, kernel is actually a deeper thing here, but for now, it's just between the devices, and these are the physical layer here. This like you have to have a kernel for the instruction from application and the operating system. It goes to kernel, and from there, the instructions goes to the physical hardware devices. Okay. Let's see what's the right here. There is a picture here too. So kernel is in the middle of everything here. Time manager, memory, synchronization, task. Mm. So this is what I mean. The picture is if you're sending if you're loading an application, and the application like for example Word document. If you load that Word document, it gets loaded into memory, but that instruction is passed through kernel. That instruction goes to kernel, and then kernel talks to the hardware, and then goes back, and then acknowledgement. So it goes back and forth here. So the kernel, you have to have the kernel. By the way, all these things are written in binary. Okay, so this is binary here, zeros and one. This is what the machine reads. No matter what you're typing in there and all that, if you're typing any command, anything, those are human readable. But this is what machines get. Okay, zeros and ones. This is what is called machine language here, binary. Okay, so the kernel initializes. So the information from there it goes to the kernel here. Okay, so the bootloader is the BIOS is responsible. It kicks off the machine, and then it passes the control to bootloader. The half of the bootloader is sitting in MBR, and half is sitting in /boot. Okay, so there are two stages of bootloader, first and second. First stage, it kicks off MBR, and MBR is the one that passes control to the kernel here. So second stage of bootloader initializes the kernel. I'm sorry. MBR bootloader initializes MBR, master boot record, and master boot record is where the kernel initializes on the second stage of bootloader. Okay, so now the kernel is live. When the kernel is live, it's going to do its thing here. What is kernel going to do? Kernel is going to detect all the hardware. Kernel is going to detect all the hardware. Then it also initializes the software for hardware. Okay, initializes the software for hardware. What is that? It's called the drivers. Kernel is going to detect all the hardware, initialize the software for the hardware. Okay, what is and then this is for Windows. Drivers is in Windows world, and then mod probe is for Linux. Okay. All right. So now what happens is kernel is all these things is let me reboot one more time here. All this thing is happening right now. The BIOS has initialized already, and then let me push the escape key. So it's going through this thing here, and at this moment it's already past kernel. Your processes, okay. Okay, so it went up to grub menu here. Okay, and then what it does is it also mounts the root file system into read-only mode. And kickstarts the init process. Okay, is actually the init process is starting at this moment here. So what is kernel? This guy in the middle here, what he's doing is detecting all the hardware on the bottom here, and initializes the software for the hardware. So it has all these CPU memory devices. They still have their own little uh, drivers. So initializes their drivers, and then mounts the root file system here. Okay, so it's pulling that up and then putting that on the hardware in a read-only mode. At this moment, it's only doing the read-only mode, and it kickstarts the init process. Okay, so we're going to look into what is init process here. So initialization process. Okay, what happens in init process? Init process, if very first thing is it reads the /etc init tab. Okay, so we touched on this init tab, right? So what is init tab? Let's go in and take a look. We remember beginning of the class we went in there and then we fooled around in here. Okay, so init tab is actually looking to find out which run level the system should boot. So at this moment, all this is happening now. The system is realizing that what system.
It's not moving. I'm not sure if it's my screen or coming from you.
Hello.
There was
We lost screen.
yeah, it's back.
Okay. Now better.
Muzaffar, we can't hear you. Are you silent or?
Okay, can you hear me now?
Yes.
Okay, okay. Not sure what's going on here. Can you see the screen now?
It's very low, but Zafar, we can hear, but the volume is very low. It's better now.
Okay, what about now?
Yeah, it's better.
Is better? Okay.
Yeah.
Okay, so what happened so far is what happens is it reads the init file, and after that it's executing this file here, rc dot sys init script. This is a huge script here. Oh shit. All right. So I was just trying to see how many lines this one has. Has a lot of lines in here, lines of code. So this is sys init rc dot sys init script. Okay, this file it runs at one point here. Okay. 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 So this file is executed, but what is this file doing? Okay. So this file, what it does is it configures the host name, configure the host name. This file is reading other files here. So it's configuring the host name. It configures the IP address. And it brings up the SE Linux. And then it remounts the root file system. to read-write mode. So at one point, the file system was loaded into read-only mode, right? Right here. Right here, it was only into read-only mode. Now what this script did is, this script, it made the root file system, not the root directory, okay, root file system. Remount the root file system into read-write mode. Before it was read-only mode. At this point, it's in read-write mode. Okay, and also it starts the system v services. Okay, what I'm talking, what are the services here? Services is okay, so when your system starts, there are some built-in system services that starts. Okay, so there is a command chconfig, and these are all the run levels here. 1, 2, 3, 4, 5, 6, 7. 7 run levels here, starting from 0. Okay, so at this moment here, it starts the system with services based on run level. So it knows this run level 3 is starting. So in this check configuration file or check configuration utility, these are all the instructions that need to start in that run level. So for example, let me look at the easy one here. This is the IP tables here. So what's happening is, in run level 3, the IP tables is on. So it's going to load this service, okay? And then also it goes through run level 3 and see, okay, the network service is on. So it loads the network service also. So all these things are being loaded. If this is off, that means it's not loading that service. Okay? Are you clear so far? So let me just give it a quick rundown. So when you power it on, the BIOS initialization happens, and then this is usually a built-in chip on the system board. Okay, so after that, it passes control to the bootloader. Bootloader has two. It passes control to bootloader over here. It has bootloader. Bootloader has two stages. Stage 1 and stage 2. So it passes control to stage 1. What does stage 1 do? Stage 1, it resides in MBR, master boot record. This is a small space on the disk that the master boot record has. It kicks that off. Once that kicks it off, it passes control to the second stage of bootloader, which resides in /boot. So we saw in /boot that it has some files in there. Okay, so the second stage of bootloader actually particularly looks for the kernel file. Okay, so this is the kernel file, and it passes control to kernel file. And what does kernel is doing? Kernel is going to detect all the hardware, initializes the software for the hardware, which is drivers, and mounts the root file system into read-only mode. At this time, slash root, if you go into slash root, all these will be in read-only mode, not the rewrite. At this moment, it's still in read-only mode. And then kickstart the init process. What is init process? Init process is the system goes through the init file tab, and then that file, after that, it reads through the sysinit file, rc.sysinit file, and it has a bunch of instruction in it. What is that file doing? It bringing up the saved configuration. These are all the saved configuration. It does a lot more, but these are the basic ones here. And after that, it comes up to the prompt here. That means the system is ready to be used. So let me just do it one more time. So the moment it's restarting here, so it's going through all these files, okay, and then it looks for the network. It's already over here. It's already over here in one of these places.
But Zafar, is there one file where this check configuration is stored, and if it is changeable?
Yeah, check config is nothing but like a task manager. You you have this task manager, and then I think startup, something like startup here. Yeah, it's a check config as a file. We'll take a little bit deeper look. We'll be working with it a little bit more when we work further more.
Okay.
Check config is just a file that you could tell the system to do what to do in that particular run level. Okay, I'll tell you that about it. I mean, it says check config means checking configuration. That's what it is. Okay, and these are all. Let's see, where is this file sitting in? Okay, it's one is in SBin here. So what does SBin do? We talked about SBin, right? Right here. Okay, so SBin has a folder. This folder contains root user commands here. Okay, yeah. So I think you could run only as root user. All right, so I don't even want to talk about this. So this is probably in binary. So if your file is not able to read, that means it's binary. That file is exclusively written in binary. But anyway, I mean, there are a lot of things going on. It's hard to comprehend at this moment here, and not everybody is able to know what is actually happening here. All these things are all this operating system, all this is done by different people here. Not one corporation is controlling how the operating system is going. All this process has started over the years. ever since the computers have been there. Some of them wrote BIOS. BIOS has its own history. I don't know. You could look it up on that. And then bootloader has its own history. And then the all this init tab and all this in Windows. I'm sure there is some similar process here. I'm pretty sure the Windows process up until here is the same. Up starting from there to here is same, and after that this is the Linux process. So all these things are not controlled by not one organization or entity. This is being contributed by organization, people, loners, scientists, the universities. They all contribute and then try to improve on this. Okay. All right. So any questions so far? Okay. So now during the boot process, there is one thing that also happens is called grub. Okay, it happens somewhere in the middle here. Let me see. Give me one moment here. Okay. Okay. So over here it reads init process, and there is also one more process called grub. GRUB stands for, what does it stand for? Grand Unified Bootloader. Okay, what does grub do? Okay, I'll show you. So actually there is a file there. It's in the boot. Okay, so there is a file in here, grub. This is also a part of booting process. And where is that file here? Okay, so here's the grub menu here. Grub menu is actually even before the kernel here. I'm sorry, I missed this here. I should have showed you. Okay, the grub file, it's kind of not of a part of a booting process, but also it is. What it does is it's right here. First stage of okay. So this is grub is actually a part of the second stage of bootloader. Okay, so what does grub do is grub has the information for which kernel to load here. Okay, so let's see here, right here, the elements. Okay, So later on in the class, we will be doing a kernel update. So when there is a kernel update comes in, then it looks for this kernel to load here. So what this file is doing is it's actually detecting the correct bootloader. This is a bootloader. It initializes a kernel. So it detects in this file, when this file is executed, if there is more than one kernel in here, then it looks into this file and loads the correct kernel. Okay. So let me open another window here. cd/boot. Okay. this is the kernel here, and this is what it's hard written into the grub.conf, which is a Grand Unified Bootloader. So it's going to read this file here. If there is more than one in here, if there is more than one file in here, if there is more than one kernel file in here, it's going to look for the one which is hard coded into this script, which is a grub script, and it loads that kernel. Okay. So I'm going to show you where to look for that one. So Grand Unified Bootloader, when you get a countdown, this is exactly when that is being executed. Okay, here. So what we did is we actually interrupted the initialization process, the boot process. So we are at this point here. Okay, if you have more than one kernel here, you could choose it from here also. But if you don't do it, just like an init tab file, it will look at that file, and then it will load it from that file here. Okay, and then you come here and you do edit, and then now you see it's actually also more information over here. You select the second one and you do edit, and then you change the run level here. Okay. Okay, guys, I'm pretty sure everybody is confused at this moment. So
You're correct, Brother Zafar.
yeah, because I was too. To be honest with you, in day-to-day process, you won't be worrying about all that as much. Only thing is interrupting the boot. When you interrupt the boot, and where you could interrupt here, and then you edit it, and then you want to come here, and then you want to change it, and change the run level here. Okay. So we've been doing 3 here because we haven't set the run level as default to 3 in init tab. But now, only time you would be coming in here is sometimes if you did the kernel update, and then there will be 2 kernels in here. So you want to select which one to go back and forth to. Okay, when we do the kernel update process, you will see 2 kernels in here. You will see 2 kernels in here, and if it's giving a problem, you go back to the previous one. Okay, but later on, halfway through the class, you will have a better picture, because we will be coming back and forth to these files and this process, not as much, but a few more times. But it will take you some time here, maybe by the end of this course, to understand what is actually happening with all these operating systems. This is actually the start of the class. But I didn't show you during the start of the class, because I want people to get a hang of how to just turn it on, turn it off, change things around, and then be familiar in here. Then then you could understand all this furthermore. But no worry, this is just how the system is happening.
But Zafar, what is the path for grub?
For Grub,
Yeah.
it's in the boot folder. boot/grub.com.
Okay.
And so here's the thing here. All this Linux is file based, and all these files are interdependent. And one file is executing, and in that file it has some instruction to go look for the instructions for the next stage into another file. Okay. So this is what is happening here. So the grub after here. After the grub is loaded, then it looks for the init file. To load the run level. So what we did when we interrupt here, we actually went into grub, and then we changed the instruction in grub to change the init file. Instead of reading init file, we interrupted it to read at the moment what we are asking it to do. Okay, here we're interrupting here. Okay, we interrupted the graph, and then if we haven't interrupted, it would have gone on its way doing its own business, and it would have read this file, and this is where we set the run level. Or we could interrupt the graph here, and then we could change the run level at this moment here. I know it's 3, we could change it to 5. Okay, and we have done this many times. Okay, and then so now the system is going to boot into X-Windows mode. Okay, somebody says they cannot hear me clearly. Can somebody confirm that?
What do you want us to confirm, Zafar?
Can you hear me clearly?
Yeah.
They can hear me clearly. You can hear me good?
Yeah, we can hear you.
Okay. So the system is right now it's in run level, but the default is 3. Okay. Yeah.
So that's how the grub look like?
Apparently, it's complicated. It's like let's see here. Okay, yeah, let's see. What is this? Just a file. So the grub is actually happening after MBR. So let's see here. Yeah. Okay, so what I'll do is I'll clean this up a little bit after the class and I'll post it on. And this is pretty much the system initialization of boot process, okay? BIOS, then the bootloader. Okay, so let's uh, let's work on new topic. Okay, guys, don't get stressed about this boot process here. Uh, this will be an interview question. If you're gonna get an Indian guy he's gonna do interview, he's gonna kill you on this. Hopefully you guys won't get it. But I prepared a question. Just memorize the question, okay? I'll put that question into the list of questions I'm compiling, and just memorize it. Most of the time, if you in the interview, they will ask you, what is the initialization process? You just go through, run it down. I will have like a few pointers in the questions. You just memorize this, okay? But you will be asked about 25% of the time. Somebody will ask you a question about how the boot process works. Okay, so I'm gonna start fdisk. Alright, some of you guys might know what fdisk is. So let's get started on it. So for this thing, I have to shut it down. I'm shutting it down, and then I'll show you how to add a hard disk to the system. Okay, so in here, you go into settings here, and go into storage, and then select controller SATA, and then which one is this? Okay, so you have two options here: add optical and add a hard disk. So we have one here. This is the root. This is where the system is booting off. So I'm going to add a secondary disk in it. I'm going to adding a second disk in it. And it's okay. So I'm create a new disk, and and set the size to 8 GB. 8 GB is fine. Okay. And then simply click create. I'm going to remove it. Issue. Guided mode. Over here, give the name disk2, okay? Disk2. Disk2. Okay, so that way you know disk2 is the second disk. Okay, so I'm going to start the system here.
So let's say Zafar bhai, whenever you add the hard disk in this example, or we add the memory or any sort of hardware, you have to restart the system.
Uh, yes, I mean if it's a physical. Right now, what I showed you is as if you are adding a physical disk. As if you added a physical disk, you have to go into a shutdown mode and then add the disk.
Okay.
And also, some servers, they are hot swappable. That means you don't have to shut it down. But the operating system drive, I mean, there is no way you will still have to shut down in these days of age.
We lost your voice again, Zafar. You there?
Can you hear me now?
Yeah.
I don't know what is happening. I am automatically going into mute mode. But you did hear me about talking about adding a raw disk and restarting the computer?
Yeah, I got my answer.
Okay. So the moment you added a blank hard drive, what it means is it's a raw disk, okay? It's just simply blank. But how somewhere you added it, but you don't know how to check it. So the command to check it is you have to go into. Right now it's still loaded and the system knows that, but how are you gonna know? You have to use the command cat proc partitions. So over here, remember I told you proc. What does proc stands for? Anybody? /proc is memory. Right now, this folder goes away when the system is shut down. This folder is up only when the system is up and the working memory is there. So I told you proc is it has a system memory. Okay, proc, it contains active memory information here. Okay, so right now the hard drive is loaded and it's sitting in the proc folder. Let's go into proc folder. CD proc. So it has a lot of information with here. All this thing is sitting in proc. But we're not worried about that. So cat etc proc. So all right, so I have to show you a little diagram here. Okay, how does the Linux system handles okay, so in Linux, very first item for hard drive is SD. Starts with it's sitting in dev folder. Okay, I told you earlier that /dev, it has all the hardware information in it. Okay, so it contains all the device information. Okay, that means all the hardware devices. Give me 1 second here, hold on. Okay. So in Linux, the very primary drive in Linux is SDA. Okay, this is how it starts off with. Very first primary hard drive. This is also a boot drive. OS, operating system drive. Okay, so if this drive goes down, okay, if this drive goes down, That means the entire operating system goes down. Okay. And then if you have the second one in here, second one would be considered SDB. Okay, what about the third one? You go dev SDC. What about the fourth one? Fourth one is dev SDE. Okay, SDE. So all the way dev slash SDZ would be the 26th drive. Okay, so it goes from SDA to SDZ, and this is the beauty of Linux here. It could handle a lot of drives. Okay, I'm not sure about Windows. I worked into Windows world a little bit, but never really knew it could handle this many in Windows. I'm not sure. You have to find out on your own if Windows could handle this many drives. Okay, this is not end of it. Okay, now the 27 drive. If there are 27 physical drive, how is that going to happen? Okay, so what will happen is SDAA. This will be the 27 drive. Dev SDAB will be the 28th drive. And so on. It goes all the way A, then all the letters again after Z. Then after so many, if it runs out of SDAZ, dev slash SDA Z, it's done, right? So after SDAA, okay, then starts with SDAB again. Then all the way, all the letters again. So it could have a lot of drives. I'm not sure how many, but the maximum I've seen in the production environment is about 20 physical drives. No, I'm sorry, not those are the LVMs. I would say about 10 or 12. IBM holds. Okay, the physical hardware for some servers, it could hold up to 15 drives, but it depends on the configuration, how the configuration is set up. So, but to be honest with you, I've seen 15. Okay, and the logical volume, I've seen number of many of those. Many. Okay, so. Any questions so far?
You mentioned about LVM, so would you compare LVM with disk? What's the difference really?
No. LVM is logical. It's only for humans to read. The physical drive is the physical drive. Right now, I'm just dealing with the physical drive right at this moment. Then tomorrow or next week, then I'll start LVM.
Okay, my question was basically, so one LVM can spread over more than one disk, or the disk.
Definitely. Okay, so now let's focus on SDA. SDA, what it does is it makes let me just go here, CD slash this is a 16 GB. This is a 16 GB SDA, very first drive. Okay. When we install the operating system, it made the built-in partitions with SDA1 and SDA2. If it has two partitions, what are partitions? Partitions are nothing but, it's like if you have an open warehouse and then you could build some, you could break that warehouse into multiple rooms, multiple big rooms. It's called partitions. Okay. So I have here. Let's see here. So I have here 8 gig of 16 GB of 16 GB of disk space. Okay, let me find a picture of a disk. Okay, so this is a good example here. Oh, okay, so this disk is about 16 GB. So let's see here. This is SDA. Let's work on SDA first. dev/SDA. So in this example here, SDA has two partitions. What is partitions? So this is the entire disk, 16 GB, and the partitions there are two partitions in there. The system uses the partition system for it to be manage the disk here. So it doesn't have to be same exact size partition. It could be 4 GB here, and then the rest is 8 GB or 12 GB is the rest of the partition. Okay. And then you could have multiple partitions here. In this example, it's just SDA1 and SDA2 /dev SDA1 and SDA2. So if you have like a third partition, what will the third partition be? SDA3. SDA2. Okay, good. So now this is what I explained you about the partitions here. So this entire full disk is here, and then you could make a smaller partitions in here. Okay. Okay. So right now, the disk, the new disk we created, a raw disk, is just added there, and it's sitting around and doing nothing. And we don't even have a way to figure it out how to check it unless we run this command. Okay. All right, so we successfully ran this command, and now what we're going to do is we're going to try to use the disk here. Okay, so and also remember, when you go on to a job, just because the disk is a loner or sitting around on its own, that doesn't mean it is not being used. Okay, how would you find out if the disk is being used at all or not? You go into the folder cd/dev, and then you do ls-l, and then grep for sd and asterisk. Oh, grep. Okay. Okay. Okay, anyway, the command is not working as expected. But what you do is you go into cat etc partitions. No, I'm sorry, cat proc partitions. Okay, it will have a partition information here. So let's go ahead and take a look at this disk here. So you type ls -l and then grep for sdb. Okay. So the owner of this file is root, and if it says disk, that means this disk is the disk is owned by the root. So this is not being used by any other application. You got to be careful. You come here, and if it says the name of the application, for example, Oracle, and it says Oracle here, that means the system is being used by the Oracle operating system. I mean, Oracle application. So be careful not to mess with it, okay? Because even though the disk is not being used by the system, it's just listed as SDB, and it's not showing anywhere in the system. That doesn't mean it's not being used by the by any other application. So you just have to come here, and first you have to do cat proc partition and look narrow down your disk, and then come here and see who the owner is. Okay. So let's see here. Okay, I'm not finding what I'm looking for. So, but here, so you do cat proc partitions, and then you go in there, and you run this command. Okay, and if you see, once you see the root is the owner, once the root is the owner, then you could proceed. Okay. All right. So now we're going to proceed with the fdisk command. So there is a old fdisk command. It's been there for ages. So the command is you type fdisk.
But Zafar, can you run this grep SDB command one more time on the screen? LSL. I want to see where the owner is.
So you have to be in dev folder. ls-l grep sdb.
Okay. I was using STX. Sorry.
Okay. Okay, so
So Zafar, why you have to go actually in the date directory, or you can use the relative path here too.
the second part I couldn't hear you.
I said you have to use the absolute path, or you can use the relative path over here.
I don't know what you're talking about.
I mean, you have to go to in that directory, the cd/dev.
Yeah, you have to go into dev because dev folder holds all the hardware information.
Okay.
Right here, I mentioned you somewhere, right? It contains all the device information. Okay, even the device is not being used, it still have information here because of our booting process. Booting process, it loads the somewhere here. Kernel detects all the hardware. It detects all the hardware, initializes software, and all those. It keeps it ready here. Even though we can't see it, the system could see it.
Can you put in the notes in the Word document dev right before ls?
Okay.
Thank you.
Normally, I don't know why this command is not working. I like this command. Usually I do SD and asterisk, and let's give it a minute here. Memory exhausted.
But Zafar, if you use H switch, then you will get that information. Which
Oh, like this?
yeah.
You said H?
Yeah, that's what I used.
Is it working for you?
No, sorry, I was not using asterisk. Sorry, I'll take.
The first command should work. No, you're right, Zafar. It's the SD steric. It should work.
SD asterisk should work, right?
Yeah, you're right.
I don't know why it's not working. Oh, okay. I shouldn't be grepping. Okay, now this is what I was looking for. Good. Okay, so you could see SDA in here is owned by root, and within SDA there are two partitions, partition 1 and partition 2. It's owned by root. Okay, SDB is also root. If you see in here Oracle or Postgres or anything other than root, then don't proceed it. Okay, you're gonna be in big trouble if you end up deleting the data. When dealing with this fdisk and LVM and everything, be very very careful. If you are doing it, if you know it for 100 years, you still check with somebody. Okay, how you want to do it. All right, let's move forward here. So this command works. Okay, good. Okay, so somebody says that my voice is not clear. Is this true? Or I'm going in and out? I don't know what's happening today. Okay, so I'll try to. So the fdisk command is you do fdisk -l and you type sdb. Okay, oh I'm sorry, /dev/sdb. Okay, so it gives you information about the disk itself. Okay, if it had any partition or anything, it will give you that information. Let's take a look at SDA. Okay, so if when you type fdisk-l/dev/sda, it gives you a disk information here, and also it gives you the partition information here. Okay, and it's telling you what kind of file system it is. It is using a Linux file system, and the partition 2 is using LVM, Logical Volume Manager. We'll go deep into LVM. And most of the time, you just worry about the size here. So it's showing you in bytes, so you have to kind of calculate that into, let's see, LH. Hmm. Out, switch, heads. All right, so we don't have much help there. So let's format the blank drive here. So we have this blank drive SDB. What we're going to do is we type fdisk/dev/sdb and you hit enter. Okay, so what will happen is you get into the and then you get into the fdisk portion here, and you type M to get the help menu here. So what we're going to do is we have so many options in here. M to print the menu, so it's printing this menu here. Okay, I want to see if there are any partitions already on this disk or not. So if I want to check the partitions if the partitions are on the disk, I just simply push P, and there are no partitions in here. Okay, this is the same information as we got here earlier, partition information. All right, so let's go to M again. So these are the flags you could toggle. I barely use this. I never use that, and then I haven't used this. In the production environment, if there is a smallest problem with the disk, it just gets replaced. Okay, because in all these big IT companies, they have deep pockets, and they don't care about to try to reuse the disk. If there is a little problem with the disk, it just gets replaced. That's it. So let's focus on creating a new disk. So I have to type N here. Okay, I'll type N and hit enter. When I type hit enter, it's telling me which partition I want to create. I always create primary partition, and you could create up to 4 primary partitions on each disk. Okay, so I'm going to type hit enter. Okay, suppose you push P to hit enter. Okay, so let me write this down. N to create new partition, and then you primary partition P for primary. Okay, and it's telling you partition number. If you just simply hit enter, it will take number 1. Oh, maybe not. You push 1. Which partition you want to create? You want to create the partition number 1. And then over here, how many cylinders you want to use. And then you just hit enter here. It took the default cylinder, okay, 1024. And here you want to specify how many gigs you want to make this partition. So I want to make a plus. I want to make about 4 gig partition. I type plus 4G. Okay, and I hit enter.
Question.
Yeah.
So from 1 to 4, did you choose 1?
For primary, I push P, and then the partition number I put a 1. So it's set as a partition 1. I'm sorry. Right here.
Because if I put the partition is already is defined. It's a delete before re-adding it. So should I do a re-edit?
Oh, I'm not there yet. I would have been saying how to do that in next step or later on. Right now,
Okay.
we're working with the raw disk and we're just creating a new partition. Okay, so we have done this, and then if you push P, it will give you the partition information here. Okay, so right now, what we did was we created a partition. Now see, it automatically took the partition number 1, and then the starting block is 1 and ending block is 523. And these are how many blocks it has, and it has the ID of 83. So let's go ahead and take a look what ID 83 means. And then here's the list of known partition. Push L. Okay, so where is number 83? Okay, so number 83 is Linux. Okay guys, here are so many different kinds of partition tables you could create here, okay? It has FAT, file allocation table. These are all the older ones. File 3, FAT 1, and I don't even know what this LBA and all this stands for. The only thing I always worried about is number 83, and then I'm worried about the LVM here. 8E is the LVM. This is the one I'm worried about most of the time, and then the swap. Where is swap here? Where is swap?
The B8. Yeah.
B8. Yeah, here. Which one? B8? No, not that one. Is there a swap only? Oh, right here, maybe. This is it. Linux swap. So we'll come to that later on when I'm showing you about swap here. So let me push the menu again. When you see the menu, right now you have created the partition, but you still need to write the partition here. Okay. So how are you going to do that? You're going to have to type W. When you type W and hit enter, it will write the partition. We created it, but it's not written here. If I just quit without saving, then the changes will not take effect. Okay. So W enter. Okay. Now if I type fdisk -L, Okay, that didn't work right. So if I type fdisk-l, that partition is permanent now. It has been written into the system. And one other way you could see is cat proc partitions. So in here you see SDB, you see the entire full size here 8 gig, and 4 gig is the SDB1 partition. And it's not going to show you SDB2 because SDB2 doesn't exist. But out of 8 gig, 4 gig is being used for partition 1. Okay. All right. So I'm going to stop here today, and I may continue on tomorrow, because tomorrow I'm going to start LVM. It's a very important topic. Okay. All right. If you have any questions, just put that into the chat.
All right, thank you.
All right. Allah.